All right, 9.3b geometric series. So today, first we're going to start off with the sum of a finite geometric sequence. Now, what does it mean to be finite? It ends. It has a stopping point. All right, so to find the summation, if you have a geometric sequence, so we have a common ratio going on, this is the way we find it. You start off with your first term, and then you multiply it with 1 minus your ratio, your common ratio to your nth term. All right, not your nth term, but your number of terms that you have in that geometric. All right, and then you put it over 1 minus r, again 1 minus your ratio. Now, this is what's said to be good form. All right, if you start at 1, you go to a number, that's said to be good form, but you can work with it without it being in what's called good form. For instance, if we had a summation, let's say we start at 0 and we go to 15. How many terms would that have? 16. So my n there would be what? 16. All right, so we can work with it either way. All right, let's work at this first one. So I have a summation from 1 to 12 of 4 times 0.3 to the power of I minus 1. Well, the first thing we need to do is find our a sub 1. So we substitute in 1. That's where we start. So if I substitute in 1, now I have 1 minus 1, which is 0. Now I have 0.3 to the power of 0, which is 1. And then 1 times 4 is 4. So my a sub 1 is 4. And then it's times 1 minus, what the heck is my common ratio here? 0.3. So I have a 0.3 as my common ratio. That's what's being multiplied. And then to the power of what? How many terms do I have? I have 12 terms. And then it's over 1 minus r, which is 1 minus 0.3. And from there, I put it in my handy dandy calculator. Make sure you put parentheses around your entire numerator and your entire denominator. It's going to make you not mess up as much. Kenley, what do we get?
I didn't put it in there yet. I was looking for the phone.
Anybody, what do we get?
5.7143.
There it is. All right. All right. So now I have a summation from 1 to 12 of 4 times 0.3 raised to the power of I. Now, before I would always make you guys put it in what's called good form. And so this good form is written like this. All right? If you get to Calc 2, sometimes you're going to have to manipulate. All right? In pre-calc, we don't actually have to manipulate it to put in that good form. And so we'll show you how to do it. But we'll also show you how you can do it without putting it in good form. Okay? All right, so this first one I have is 1 to 12 of 4 times 0.3 raised to the power of I. Well, it's not an I minus 1, so I don't know what my a sub 1 is exactly. It's not 4. So if I substitute in 1, what do I get? I get 1.2. All right? So my a sub 1 is actually 1.2. And then I have 1 minus, what's my r? 0.3. And then it's raised to the power of 12 over 1 minus 0.3. All right. And then I put that in my calculator. We end up with, does anybody know the difference, literally the difference between the one we just did and this one? 4. Okay. It's because last time, what was my a sub 1? 4. All right. And so it was kind of one term off here. Now, if I were to put this, what's said to be good form, I'd still go from I equals 1 to 12. But my first term would be 1.2. And then I'd have 0.3 raised to the power of I minus 1. This summation down here and this summation right there is the exact same thing, just written a little bit differently. Okay? Now, in pre-calc, you don't actually have to do that. Is everybody hearing me? Okay? If you wanted to, you can manipulate it that way, and you could work with it in that good form. I'd like you to try these two. All right, this first one. What's my a sub 1? 64. And then times 1 minus, what's my ratio? Negative 1/2, the quantity of negative 1/2. And how many terms do I have? 7. So that's why we have a 7 there. And then it's 1 minus negative 1/2 again. And so when we put that into our handy dandy calculator, it gives me a nice number of 43. Very nice. All right. All right, this next one, I'm going from 0 to 20. Before we even do anything, how many terms does this one have? 21 terms. All right, so if we substitute in 0 to find my first term, what would be my first term? 3. And then times 1 minus my ratio of 3/2 to the power of what here? 21. 21 over 1 minus 3/2. All right, and if we put it into our calculator correctly, we end up with 29,000. All right. Pretty good. All right. So those were for finite series. All right, so now we're going to do an infinite geometric series. So what does it mean to be infinite? Doesn't stop. All right, it keeps on going forever and ever. It's denoted if we have a summation to infinity, all right, or it has a dot, 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 or a dot, 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 dot. It keeps on going forever and ever. So this is the way to do it. So if we have, first of all, if we have an absolute value of a radius, it needs to be less than 1, not a radius, a common ratio. If our common ratio is less than 1, then we can actually use this formula. And the formula, it's real simple. It's just our first term over 1 minus our common ratio. So, for instance, if we have, let's say, 3/2 as my r, okay, it's being multiplied term by term for 3/2. Can I actually use this formula? I can't. However, what if we have our ratio as a negative 2/3? Can I actually use this formula? Yes. All right. So we need to check that every now and then to make sure we can actually use this. Hint, hint, nudge, nudge. Think I'm going to put something that's greater than 1. Yeah. You're going to be able to get a number. It will give you an answer. It will spew out a number. However, can we actually do it? No. Even though the formula will still work, it doesn't actually equate to something that we can do. All right? So here we go. So now I have a summation from 0 to infinity of 4 times 0.6 raised to the power of n. So I'm going forever and ever. All right? Well, what's my first term? If I substitute in 0, what's my first term? 4. So now I have 4 over 1 minus, what's my common ratio? 0.6. First of all, is this 0.6 less than 1? Yes, so we can do it. So now I have 0.6 down there. So 1 minus 0.6 is 0.4. 4 divided by 0.4 is 10. All right. All right, this next one. I got 3 plus 0.3 plus 0.03 plus 0.003. Well, what's my common ratio? What's being multiplied each time? 0.1. So it's being multiplied by 0.1. That's my common ratio, or 1/10. All right. So I don't have to set it up anyway. If I don't want to, I could just leave it like that. So what's my first term? 3 over 1 minus 0.1. And what do I end up getting? 3.3 repeating, or 10/3. Okay. Now, couldn't you recognize that? That would be 3.3 repeating right there. All right, you really could. Okay. However, the formula, it will still work. It will still work there. Okay. All right. I'd like you to try these. First one. What's my a sub 1? 1. Over 1 minus, what's my ratio? Negative 1/2. So we end up with 2/3. All right. This next one, what's my common ratio? 3/4. So my r is equal to 3/4. So, is that less than 1? Yeah, so we're still good. We can do it. All right, so what's my a sub 1? 8. Over 1 minus 3/4, and we end up with 32. All right. we're going to do a couple more together, but worksheet 9.3b. Worksheet 9.3b. Used to be, you'd balance it at your shoulder, okay? You would actually, if you hit it in the water or something like that, you'd take a drop, you'd bounce it at your shoulder, all right? And then, but now they changed the rule a couple years ago that you drop it at your knee, all right? But anyway, I'm going to bounce it at my shoulder, okay? We're going to do an example. Let's say that's about 6 foot, okay? I'm about 6'2", this is about 6 foot, all right? The ball bounces up each time, right? The ball bounces up each time after it hits the ground, all right? What percentage do you think it bounces up? About what? What? 3/4? Is everybody gonna go 60%? What are we gonna go? We gotta go with something. 5. You're so funny. All right, 60%. Is that what we're going with? 60%. All right. So it bounces up 60% of the time. All right. Now, is that golf ball still bouncing? Yes, it is. Yes, it is. The golf ball is still bouncing. It's bouncing up 60% of what it did last time. Mariah's like, I don't see it bouncing. It's bouncing. All right, it is bouncing up 60% every single time. If it does it on the first time, why wouldn't it do it on the 100th? You know what I'm saying? It is bouncing up 60% each time. Still bouncing. Okay? So we're going to actually find a summation of how much it bounces up. That's what we're going to find right now. All right? So you said my A sub 1 is 6, right? Bouncing about 6 foot? And it's going to be 60% of that. All right? So every time it bounces, it's going to bounce up 60% of that. And so I'm going to raise that to the power of n. And I'm going to start at 0, and I'm going to go to infinity. All right? That would be my rule for what we just did. All right? So my A sub 1 would end up being what? 6. Over 1 minus 0.6. So how far did that golf ball travel? $15 feet. So that golf ball bounced up 15 feet if it goes on forever. Is that golf ball still bouncing? Yes, yes it is. All right, so on number 12, it asks for what? What does it ask for?
Use summation notation to write the sum.
All right, so we just need to write in summation notation. All right, fantastic. All right, so we're going to write this one in summation notation. All right, so I could start this out by what's my first term? 15. All right, I could write it out as 15. Now, where do you want to start? Do you want to start out at 0 or 1? I don't care. Which one do you want to start out at?
1.
You want to start out at 1? All right, it's going to make our life a little bit more difficult, but that's fine. All right, and then what's my common ratio? Negative 1/5. So I have a common ratio of negative 1/5. Now, because I started out at 1, what's going to be my exponent? N minus 1. All right, my exponent is going to be n minus 1. Okay, if I started out at 0, what would be my exponent? N. Okay, but in this case, you guys want to start at 1, so we're going to use n minus 1. All right. Now I need to figure out what's going to be that upper part, and that's the hard part. Some people guess and check, and that is totally okay. All right, it's totally okay to guess and check here. All right, you just start picking out random numbers, and you figure out which one works. Okay, you start picking like 8. Well, let's see if it gets me negative 3 over 625. Is everybody hearing me? Okay, you could do that. It is not a terrible way. Okay, however, I'm going to show you the algebraic way of doing it. So this is what we do. We actually need to set our rule equal to our last term. So I'm going to have 15 times negative 1/5 to the power of n minus 1 is equal to negative 3 over 625. All right. Now, I need to get this number with the exponent equal to a number. So I need to first divide by 15. So we're going to divide by 15, and we end up with negative 3 over
9,375.
all right. is equal to a negative 1/5 to the n minus 1. Now, once we have that, all right, once we have that, I need to get to n. So how do I get that thing down? We're going back to chapter 3 or algebra 2. What? Kinda. I use a log. I natural log it to get that thing down. So I natural log both sides. So now I have n minus 1, and then I have natural log of negative 1/5 is equal to a natural log of negative 3 over 9,375. Now, if I were to type in the log of negative 1/5 and a log of negative 3 over 9,375, it's not going to work because a log can't handle it. So all I'm going to do is just make them positive. Okay, I'm going to manipulate it a little bit. Now, I need to get this n minus 1 equal. So first I'm going to divide. So now I have n minus 1 is equal to a natural log of 3 over 9,375 over natural log of 1/5. And then what's my last step? I add 1. All right, so now I'm going to add 1 to both sides, and so n would equal that. Now, let's go ahead and type that into our handy dandy calculator. So n is equal to 6.